Hi. I promise this is the final video in this set. All right, so this last section, we're going to cover APR, EAR, and compounding. So what I'm going to do is I'm going to introduce the concepts of simple and compound interest and talk about why those are important. I'll talk about APR and then the effective annual rate. And then finally, we'll talk about amortization, or amortization if you're British. So let's go ahead and get started. All right, so what is simple interest and what is compound interest? Well, simple interest is just interest that's earned only on our original investment, only on our present value, as you might want to think about it. It's that initial amount that you've invested. It's that principal that you've put down. Compound interest is a case where you earn interest on the interest that you've already received during the investment period. So for example, I guess I should say most investments, most loans, most financial assets use compound interest. I'm actually hard-pressed to come up with a real-world example of simple interest, short of APR. So why don't we just get into the differences between these two? All right, so there's a big difference between simple interest and compound interest, and it comes over longer period investments. So with simple interest, let's say that you've invested a certain amount of money, let's say $100, and you expect a 10% return on that investment. Well, at the end of year one, you will, as a result of that investment, have your initial amount, that principal of $100, plus the interest that you earned on that investment, so 10% times 100, which is $10. So at the end of that first year, with simple interest, that initial investment is going to be worth $110. Now, simple interest means that you do not earn interest on the interest you've already earned. So the interest you earn in year two is exactly the same as the interest that you earn in year one. So 10% times your principal of $100. So your total interest that you earn in year two is $10. What this means is that if you're calculating the value of an investment that uses simple interest, your interest always stays the same, the amount of interest that you earn every single year. So with simple interest, this investment that has a time to maturity of 2 years and a return of 10%, the future value of that is just going to be $120, assuming you invest $100 today. Now, with compound interest, like I said, you're earning interest on that $10 of interest that you've already earned. So the way we calculate the future value is by using the time value of money formula. We just take our $100 principal, or present value of $100, and then we multiply that by 1 plus our return to the power of the number of years that we're investing for. So in this case, 2. So we find that the future value of our investment, assuming compound interest, is actually $121 as opposed to $120 with simple interest. So obviously that extra dollar is coming from the interest that we're earning on the interest that we earned in year one. So this is why compound interest is so important. The longer that we hold an investment, the more interest we're earning on interest that we've already earned. All right, so let's look at an example. What is the future value if you were to invest $1,000 at an interest rate of 5% for 10 years with simple interest versus with compound interest? Well, what I've gone ahead and done is calculate the answer to this problem in Excel. So in green, we have the amount or the future value of the investment, assuming simple interest. The peach color indicates the future value of the investment at the end of each year, assuming compound interest. Now notice that in the first several years, the future values are relatively similar. Say at the end of year 4, it looks like the future value of the amount that we invested with simple interest is about $1,200 versus it's $1,200 and we'll say $5 for the compound interest investment. But notice the longer we invest, let's say over 8 years or 9 years or 10 years, the greater the difference between these two values. So in year 10, we can see a sizable difference in the future value of our investment, assuming compound interest versus our investment if we are only using simple interest. Why is that? Well, it's because over time, or rather the longer that we're investing for, the longer the period of time that we have to earn interest on our interest. So if we were to look at what happens over longer periods of time, let's say 20 years or 30 years or 50 years to the value of our investment, or the difference between our future value with simple interest versus compound interest, we would see an enormous difference in that future value. But here you can see it already. All right. Now, when we talk about simple interest and compound interest, we inevitably have to talk about APR and EAR. So APR you've almost certainly heard about in the real world. It stands for annual percentage rate. All right, so what is it? Well, our annual percentage rate is the number that is required by law to be reported anytime an individual or an investor receives a loan, or let's say, well, I guess I could give you all kinds of different loans that where the individual or the company receiving the loan is required or entitled to an APR. So home loans, so mortgages, auto loans, home equity loans, all of these, if you are receiving this loan, you are entitled in the United States to receive the APR. You are entitled to that information from the individual or the business or whatever organization that is providing you that loan. Now, the APR is nothing more than the periodic rate or the periodic interest rate multiplied by the number of periods per year. So, for example, let's say that you go to the bank and the bank says that they will give you a loan with a 2% monthly interest rate. Well, that 2% rate is our periodic rate, and since it's a monthly rate, we have 12 different compounding periods per year. That means that our APR is just 2% times 12, so 24%. And, well, that's a pretty horrible APR from our perspective as the recipient of that loan. Now, the EAR is a little different. It's the effective annual rate. This rate is not required to be reported by lenders. Why? I have my suspicions, but I have a feeling it has something to do with lobbying. I should probably back up that statement with fact, but I have not done legwork on that. Right now in the U.S., only the APR is required to be reported by lenders. Now, the EAR is essentially our way of comparing different APRs. So you might have a case where you go to two different banks and to get a loan for, let's say, $10,000. And one bank might say, we'll give you a loan with a periodic, an APR compounding monthly of 13%, and the other bank might offer you a loan with an APR of 14% compounding daily. Which is better? Well, because they're compounding over different periods, one is monthly, one is daily, it's hard to know. The EAR is the calculation or the number that makes those two values comparable. So it's a very simple formula that we use, and it allows us to scale up APRs to an effective annual rate. All right, so the formula is this. Our EAR is equal to the quantity of 1 plus our APR divided by the number of compounding periods per year to the power of the number of compounding periods per year minus 1. So we can use this formula anytime we want to compare two APRs. So say in that previous example I just gave, you can calculate the EAR of the one that offered the monthly compounding APR to the loan that was offering you the daily compounding APR. And if one's larger than the other, all else held equal, you're going to go with the one that offers the lower APR. All right, so that's that. This is a formula that is frequently used in finance, particularly with lending. Now, if you're wondering whether there's an easier way to convert EAR to APR, the answer is an emphatic yes. The way we do that is by using the ICONV functions on the BA2 calculator. So the ICONV function allows you to convert an EAR to an APR and vice versa pretty simply. All you have to do is know 2 of 3 pieces of information. So for example, if you want to know the EAR, you need to know the APR and the number of compounding periods per year. If you want to know the APR, you need to know the EAR and the number of compounding periods per year. Now, let's talk about where you find this ICONV function. It's actually very easy to find. It's going to be right above the 2 button on the BA2 calculator. So if I hit second and 2, you see this nom. Remember that, like I said, our APR is a nominal interest rate. So this is going to be our APR. If we hit the down arrow, we see this EFF. This is going to be our effective annual rate. And lastly, we have this C divided by Y. This is our number of compounding periods per year. Right now it's set to 1. So let's say we want to know the EAR of a loan given that, let's say, our nominal interest rate or our APR is 7%. So I'll hit 7, enter. And our number of compounding periods per year is 12, meaning that this loan has an APR that compounds monthly. So I'll hit 12 and then enter. If I use the up and down arrows to go to EFF, I can calculate our EAR of this investment with a 7% APR compounding monthly by simply hitting CPT. So this, once I hit CPT, this 7.229%, or the 7.229, this tells us that the effective annual rate of this loan with these characteristics is 7.23%. So that's how we use the ICONV buttons. Feel free to use those buttons or the formulas. You're going to get the result the same either way. This is probably a little easier than memorizing a couple of formulas. Your choice. All right, let's go through a couple of examples. So let's say you're given 2 savings accounts that you can use to park your money, both at, each at a different bank. So the first savings account offers you a 5.25% rate. So that's a 5.25% APR with daily compounding. And the second savings account offers you a 5.30% APR with semi-annual compounding. All right, so let's talk about how we calculate which savings account is going to offer you the higher interest rate. Well, we could do 2 different things to calculate our EAR, that effective annual rate that we use to compare those 2 savings accounts' interest rates. The first is the formula. We could use our APR to EAR formula and just plug in our APR and our number of compounding periods per year. So with this first account, all we have to do is plug in 5.25% as our APR and divide that by 365. Why 365? Well, it's because we have daily compounding and there's 365 days in most years. So we're going to take this quantity, 0.0525 divided by 365, add 1, and take that to the power of 365 and subtract 1. The reason we subtract 1 is to get rid of that principal. If we didn't, we'd have an EAR of 105%, about 105%, but we always get rid of that principal by subtracting 1 here. So what we're left with is an EAR of 5.39%. Now, if we wanted to do that same calculation using the ICONV buttons, all we need to do is click the ICO second and then 2, and then set our nominal interest rate and our number of compounding periods, and then compute our effective annual rate, or EFF. So our nominal rate here is our APR, just 5.25%. And we're going to enter it in percentage terms, so 5.25. And we're going to lock it in by hitting Enter. Next, you're going to go down to the C divided by Y button, or function, and you're going to put in the number of compounding periods per year. In this case, because we have daily compounding, our entry is going to be 365. Hit Enter again, and now scroll up to EFF and hit Compute. And so when we do that, we find that our effective annual rate, EFF, is 5.3898. We're going to round that to 5.39. That's how I got 5.39 here. All right, now let's work on the second account. Well, with our second account, we have semi-annual compounding, which means that we have 2 compounding periods per year. So what we're going to do is we're going to take our APR of 5.3%, divide that by 2, because that's the number of compounding periods per year we have, add 1, and take that entire quantity to the power of 2, or number of compounding periods per year, and subtract 1. That's going to give us our EAR. In this case, our EAR, using the formula, is 5.37%. If we wanted to do that on the BA2 calculator, all we would have to do is set our APR, or nominal rate, as 5.3%, or 5.3. Go down to C divided by Y and hit 2, Enter, and then scroll up to EFF and hit Compute. And we get exactly the number that I reported here, 5.3702 and change. So, that being said, once we've done that, we can now compare the interest rates of these 2 savings accounts. And what we find is that even though this first savings account has a lower APR, it has a higher EAR. So when we compare these 2 savings accounts, if everything else is equal, we would want to park our money in this first savings account. Why? Well, it's because it's going to pay us a higher interest rate for any cash that we have in that account. Now, I will say that there's a very straightforward relationship between the number of compounding periods per year and the effective annual rate. As the number of compounding periods increases, the effective annual rate is going to increase, because remember, we're using compound interest. The number of compounding periods per year, as it increases, it means that you have more opportunities to earn interest on interest you've already earned. Now, this amount is going to be relatively small. I mean, we're dealing with fairly small percentages here, but this is a clear relationship. The number of compounding periods is positively associated with the effective annual rate. So if you increase the number of compounding periods per year, you're going to increase your EAR. All other things held equal. All right. Now, let's take a look at some additional examples. Now, if you want to know what your APR is and you know the periodic rate, the way we do that is simply by taking our periodic rate and multiplying it by the number of compounding periods per year. I mean, we're just using the formula I gave you a few seconds ago. So, for example, if you know that your monthly rate is 0.5% or 50 basis points, our annual rate is just going to be that 0.5% times the number of compounding periods per year, aka 6%. Now, if we, let's say, have a monthly, let's say we know that our APR is 12% and we have monthly compounding, we can essentially use that same formula to calculate our periodic rate by dividing our APR by the number of months. In this case, we divide 12% by 12 months and get our periodic rate of 1%. All right, so suppose we could probably skip by this one. All right, now let's rearrange our formula. So in our previous examples, we were using our APR to calculate our EAR, but we can rearrange that APR to EAR formula as such. So if we wanted to calculate the APR, all we would need to do is multiply the number of compounding periods per year by the quantity of 1 plus our EAR to the power of 1 divided by number of compounding periods per year, and subtract 1. Close brackets. All right, so let's take a look at an example of this. So suppose you wanted to earn an effective rate of 12% and you're looking at an account that compounds on a monthly basis. What APR must be paid in order for you to earn that 12% EAR? Well, we know our EAR, and we know our number of compounding periods per year in this example, which is 12 because it compounds monthly. So all we have to do is plug and chug. So we have M equal to 12, so we just take 12 times 1 plus our effective annual rate times 1 divided by number of compounding periods per year, and subtract 1. And what we find is that our APR that compounds monthly, it would have to be 11.39% in order to give us an effective annual rate of 12%. So what this is essentially saying is that if we wanted to ensure that we earned a 12% investment on this account, let's say we put our money in a savings account that offered 11.39% with APR with a monthly compounding, that would give us 12% at the end of the year. In other words, if we, let's say, put $100 in this account and it had an APR of 11.39% compounding monthly, at the end of the year, we would have $112. All right, let's talk about the last topic that we have, amortization. All right, so what is amortization? Amortization is essentially referred to as the gradual repayment of a loan. We see amortization all over the place anytime you receive a loan and then make a fixed payment. So for example, if you go to a car dealership and buy a car and then you have a monthly payment of, let's say, $212. That was mine. I bought a cheap Honda Civic way back in the day that I'm still driving. So anyway, amortization is a process by which we calculate the regular payment that is going to be associated with a loan. And when we amortize the loan, we can create what's called a schedule or an amortization schedule, and we can determine exactly how much of the principal is left to be paid. So let's go ahead and take a look at how this works. So I think it's best to use a fairly simple example. So let's consider a case where we received a 4-year loan with annual payments. The interest rate is 8%, and the principal amount is $5,000. This is the amount that we're borrowing. This is the amount that we're going to have to pay back. Now, what is our annual payment? This is the first step in building an amortization schedule. A schedule, or essentially a table that details exactly how much principal and how much in interest you're paying with each annual or monthly or regularly fixed payment. So first step in building an amortization schedule or amortization table is calculating your regular payment. Well, in this case, because we have a 4-year loan with annual payments and our interest rate is 8% and our principal amount is $5,000, we know that our N is 4, our I divided by Y is 8, and our PV is negative $5,000. The reason, I guess we could use $5,000 or negative $5,000, but I just wanted this payment to be positive, and if we have a negative PV, that's going to make this payment positive. So let's go ahead and work this on the financial calculator. So I'm going to clear my time value of money buttons, and as you can see up here, we are in beginning mode, which we need to correct for, so I'm going to hit the second payment, second begin, and now we're in end mode, so we can actually calculate the annual payment associated with this example. So n is equal to 4, I divided by y is equal to 8, negative $5,000 is equal to our FV, and at the end of this amortization schedule, we are going to owe nothing. This is one characteristic that defines all amortization schedules. Essentially, our FV is always equal to 0. Why? Because after we've made all of these regular payments, we owe nothing on our car or our home or what have you. So that's it. We've got 4 of these 5 variables calculated, and we need to know our regular payment. In this case, I'm going to hit CPT and payment, and that gives us our regular payment of $1,509.60. All right, that's step 1 of building any amortization schedule. Now, once we know how much we're going to be paying every month associated with this loan, to repay this loan, we can break up that $1,509.60 into both interest and principal, and we can actually see how much we're going to owe at the end of each period. The way we do this is by creating a table with 5 columns. The first is our beginning amount that we owe. So it's the amount that we owe at the beginning of the year. So at the beginning of year 1, we start out owing the total value of the loan, $5,000. We know our payment in every period is the same, this $1,500 and change. And then we can calculate the interest portion of the payment, or the portion of our payment that is comprised of interest, by taking our beginning balance, so in year 1 that's $5,000, and multiplying that by our interest rate of 8%. So in this case, if we want to know exactly how much we're paying in interest in this first year, or associated with this first year's payment, all we have to do is take $5,000 and multiply that by 0.08. In this case, our interest portion of this $1,509.60 payment is $400. The remainder, whatever is left, that's our principal. That's what we're actually paying toward our loan. So all we have to do to calculate our principal is just take our beginning value and subtract the value of our interest, in this case $400. So we'll just take, in this case, to make it simple, negative 400 plus 5,000, that should be the value of our payment, $1,509.60. So in this case, our principal, or the amount that we're paying in this first payment toward the actual amount that we borrowed, is $1,109.60. Now, the result of this is that at the end, we still owe the beginning value minus the principal for an ending value of $3,800 and change. So basically all we're doing is just taking that beginning balance of $5,000 and subtracting the amount that we paid toward the principal, or $1,109.60. And there we go. We're done. So our ending value for year 1 is automatically going to be the beginning value, or the amount we owe at the beginning of year 2. So we repeat this process all the way until the end of year 4. And if we've done it correctly, the future value, the final value of this loan, should be equal to 0. Although if we're doing it on a calculator, a lot of times we have a rounding error, but we should get something very close to 0. So that's it. That's how we create an amortization schedule. These are used all the time when we're deciding exactly how much is still owed on a loan. If you have any kind of mortgage and you've made, let's say, 10 payments on your home, it's going to be an amortization schedule that tells you exactly how much you still have left on your home to pay toward your home, to pay off your mortgage. So that's why these things are so important. And I suppose that's really all I have to say about that.